Hi, Mika.
Hello.
Thank you very much for accepting to do this kind of interview. That is a topic that is really important for us all, and that, as you mentioned before, close to your heart. So let's start, first of all, with you telling us a bit who you are and about your background, please.
Sure. So first of all, I'll introduce myself. I am Michał Zieliński, and as you can hear from my name, I'm clearly not from those isles. In fact, I'm Polish. So I have been within the field of academia for quite a few years now, and the common topic throughout my career was an interest in two fields. The first one being microbiology. I loved seeing the small, the unseen. And the second one is drug development. So I have originally gotten my degree from University of Dundee, where I specialize in both biological chemistry and drug discovery, as well as molecular microbiology. And following that, I did my PhD at McGill University in Montreal, Canada, where I combined those two passions of mine, and I studied for 7 years the field of antibiotics and how the old antibiotics are slowly and unfortunately starting to fail us. As of recently, I have begun working for a multinational company testing drugs candidate for biological safety. So that's a wee bit about myself. And yes, hi.
Wow, 7 years in the area of antibiotics. Wow, that is
Yes.
brilliant. And from what I've read, it's really scary, the fact that antibiotic-resistant microorganisms are expected to increase the number of casualties to 10 million yearly by 2050. Currently is at 0.7 millions. And why do you think there hasn't been an attempt to slow down this rate? Is there a failure in the system that prescribes antibiotics too often? Or do you think the clinicians think about the whys of an imbalance of our natural host bacteria? In other words, an imbalance of our microbiome?
So it's a very big question, which has many faces. In the first place, I want to pinpoint the 0.7 million deaths per annum, which is happening. This figure was from around 2018, I believe, which was a study which has been sort of initiated by the government of the United Kingdom to look at how bad antibiotic resistance is getting. However, as of last year, there was a new study, a new survey that was created, and they are now, unfortunately, disclosing that 1.3 million deaths per annum are now directly contributing towards death. So we are in a slightly more grimmer scenario, and 5 million deaths are happened where antimicrobial resistance played a part. So it's getting quite scary. And in fact, when you compare that, for example, to what we've all witnessed over the past few years with COVID, we are looking at 2.3 million deaths per year due to COVID. Whereas right now, antimicrobial resistance is 1.3 million deaths per annum. In fact, this figure might also be quite underrepresented of the actual cases, mainly because a lot of the cases within low and medium income countries are being underreported. And, that will unfortunately not be able to shed a full light onto the scale of the problem. So going back to it, I believe that the lack of new antibiotics being developed is or can be divided into two separate components. The first component, of course, is financial. We have to be able to look at the fact that we have a constant stream of new drugs being developed for cancer, mainly because cancer is an incredibly lucrative field.
Yes.
You are able to churn out drugs which, as soon as they are on the market, they can be given to any and all patients suffering from that particular kind of cancer. Where you compare that to antibiotics, the differences are very stark. The first thing you want to do with a new antibiotic is to never use it.
Yes.
As soon as you start giving an antibiotic to patients, the first thing that's going to happen, you will start exerting biological pressure on a bacteria to develop a resistance to the strain, to the antibiotic under question. And, we like to think about it as we are overusing antibiotics in a clinic, but that is frankly a drop in a sea. When you think about it, by 2030, there will be around 5 countries, namely Brazil, Russia, China, India, and South Africa, which will be using 100 kilotons of antibiotics in animal husbandry. So that is 1 plus 8 zeros kilograms of antibiotics per year. So that is an immense amount. It pales in the comparison of what's given to humans in a clinic. And of course, as soon as those antibiotics are administered to the animals in questions, chickens, pigs, beef, what will happen is those antibiotics are not fully deactivated once they go through the animals. Quite a lot of the antibiotic is still biologically active once excreted. And that will then create what's called a sub-inhibitory concentration of antibiotics in the wastewater. And that is able to really push the evolutionary pressure, because it's uncomfortable for bacteria if you want to sort of give it a human-like characteristic, but it will not kill it at the same time. So it will just exert the pressure high enough to try and allow for sort of bacteria to develop and then exchange antibiotic resistance with each other.
I wasn't aware of this. Wow.
So yes, it's in fact, quite, it is quite worrying. Another thing is since antibiotics were discovered in the early 1990s, in the early 1900s, what we had was at one point what was called a golden era of antibiotics, which is somewhere between 1940s and 1960s. In those couple of decades, we have seen a massive boom in antibiotics being found, novel antibiotics, new classes, where around over 20 antibiotics were discovered in those times. Right now, we are seeing a massive, what has been called as discovery void. There has been next to no new antibiotics being found. And this is where we're going more into the biological aspect of why no new antibiotics have been developed, or very few. Mainly, this is due to the fact that, well, again, 2 facts. The first one is all the low-hanging fruit has been sort of picked. So when we were looking at soil microbes, which is where a lot of our current antibiotics are found from, they kind of have been depleted. We found the easiest things, the most easily cultured bacteria. That because quite often is bacteria making antibiotics to fight another bacteria, or fungi making antibiotic to fight bacteria for resources. So it's sort of like biological warfare for each other. So essentially, we found the most easily found antibiotics. But, we can also think about drug discovery in a similar way that, for example, cancer would take place. So we don't have to go to nature to find new antibiotics. We can try to design brand new antibiotics. In fact, to kill or to inhibit a specific pathway, which could result in a death of a bacterium, is not that difficult. That's the easiest part, in fact. The more difficult part, I would say, is the one where to have a compound which can result in either a stop, arrest of the growth of bacteria, or killing of the bacteria. And the most difficult part is actually to get the antibiotic through the bacterial cell wall or cell membrane. This is the most difficult part, because with human cells, we have very promiscuous ways in which molecules are able to get in and out, and our cells aren't very selective. Bacteria, on the other hand, they are in this massive matrix of all kinds of molecules. If they functioned in a similar way, they really wouldn't be in a good place. So they have to be very selective with what gets in and what gets out. And a lot of antibiotics that we currently use, which have been developed from the natural sources, hijack other mechanisms in order to be able to get into the cell. So, we would have to find an antibiotic which is able to hijack a new mechanism to get into the cell, and then on top of it to then kill the bacteria. So this is incredibly complicated. Following on your further questions, because it was quite loaded, you asked if there is a failure in a system that prescribes antibiotics as well. And, it's difficult and unfair to play the blame game. However, it has been reported, for example, that towards the end of the day of GPs' clinics, they are much more likely to prescribe antibiotics because of the fatigue. The doctors no longer really want to argue with the patient that they really don't need that antibiotic for a sore throat or for a viral infection, because they're just exhausted. So there are many points of failure in which antibiotics can be overprescribed. And especially in low and medium income countries, you can also get antibiotics behind the counter. And I don't want to say that this is unfair, because in low and medium income countries, you might not even be able to go and see a medical professional to give you a prescription. But on the contrary, what that results in is you're able to get really strong antibiotics without any repercussion or any consultation, such as carbapenems or colistin. So, those are antibiotics that are really quite strong, and you wouldn't want to give freely away, but this is what happens. And it has to be something that should be somehow thought of when trying to fix the current system that we found ourselves in.
Yeah, because the experience that I had is dentists prescribing antibiotics. And then with my background and me thinking, why the need of prescribing antibiotics if I can try to decrease the number of bacteria, because we have bacteria in our bodies, is a matter of trying to balance. So if anything happens to us in terms of stress or something alike, this balance can be damaged, if I can say like that. So is there a need of antibiotics? Like, why don't we treat ibuprofen taken regularly from hours to hours to eliminate and see if your organism is able to go back to a homeostasis, if I can say like that, before prescribing an antibiotic, for instance.
This is true. However, what I recall reading about the prophylactic use of antibiotics in a dental setting, and it's really interesting because what was found is that, especially in people with certain underlying conditions, giving prophylactic antibiotic treatment can reduce a risk of, for example, a heart infection, because you would be able to get bacteria going pretty much straight from your dental setting
Yes.
onto bloodstream and then establish themselves in a cardiac muscle. And
Mm-hmm.
unfortunately, once this sort of infection has been set, it's incredibly difficult to get rid of. So, it's all about the prophylaxis.
That's interesting point, actually. Mm-hmm.
And I did have a point about prophylaxis, but of course I seem to have forget. Regarding the next one, you're talking also a wee bit about microbiome, if I understand correctly. This is another really interesting topic, mainly because what we have now is a lot of antibiotics which are able to exert their full might on essentially any and all bacteria. So you'd have broad action antibiotics. And what that causes is essentially it wipes your microbiome, your gut microbiome, almost blank, like a blank slate. It just erases it. And what that allows to happen is, I'm sure you're familiar with a bacterium called Clostridium difficile, or C. difficile for short.
Yep.
So that bacterium is incredibly common, unfortunately, in clinical settings with patients in wards. And what happens is, as soon as those patients are given a lot of antibiotics, Clostridium is opportunistic and will be able to then establish itself in the digestive tract of the patient. And it's incredibly difficult to get rid of. Antibiotics work rather poorly on C. difficile. And this is where sort of alternative treatments when it comes to microbiome can come useful, such as what has been developed as a fecal transplant. So this is an incredibly interesting technique developed to essentially take healthy bacteria from a healthy patient and then purify it a tiny bit and then administer that to a patient with a depleted microbiome. And that has been shown as an effective treatment of Clostridium difficile infections. So you'd be able to treat or attempt to treat a really rather quite debilitating illness if you want to think more organic terms. So rather than harsh chemotherapy and using antibiotics, to a more sort of re-establishing the healthiness of your gut microorganisms.
That's really interesting. Yes. That's good to hear. And the next one is that from your work, I've learned that bacteria have enzymes that act upon two main components used in antibiotics. Your aim has been to understand well the resistance caused by these enzymes. Could you explain in simple words what have you found out so far?
Sure.
If you're able
I'll
to.
be happy to. First of all, I would want to explain to the reader what an enzyme is. So
Yes,
what
good
we
idea.
have is we all hear about proteins, and dietary protein is one thing, but also we as humans, as well as bacteria, we have a very high content of protein, and those proteins can have functions. What enzymes do, they facilitate the the chemical reactions to take place faster than they normally would. And what I focused on were the enzymes which bacteria use in order to deactivate antibiotics. One of the enzymes, or one of the family of enzymes, was discovered in, I believe, 1960s or 1970s. They're called erythromycin esterases. And they have been relatively understudied and under the radar for decades. And what I've done, as I've mentioned before, I'm really interested in looking at the really small things. So I was able to figure out how does the enzyme look like in its three-dimensional form. So I would know exactly where all the atoms are positioned in relation with each other. And what that allows us to do, to us biochemists, if you know the structure of a molecule, you can use it to help to understand its function. So by having the structure of the enzyme and by seeing how the antibiotic binds to that enzyme, I was able to create more hypotheses as to how we can potentially make new antibiotics, which will be able to not be utilized by that enzyme, hopefully helping to prolong its life in a clinic. And I have reused this sort of frame of mind and frame of work in order to look at a couple more enzymes. So the first one were erythromycin esterases, which work on macrolides, which are your antibiotics, which would be, for example, given when you have a sexually transmitted illness, or if you had soft tissue infections. Whereas the second class of antibiotics I looked at are called aminoglycosides, and they're much more toxic molecules to us humans. They can cause ototoxicity, which is the loss of hearing, and they can cause hepatotoxicity, so liver toxicity. So of course they are not used that freely, but they are a very important pillar of antimicrobial chemotherapy. So we were looking at how are those other enzymes also able to disable the antibiotics? How can we really understand the relationship between a structure of the enzyme and try to use it to develop new antibiotics? And as they say, Rome wasn't built in a day, and the immediate application of my work will not most likely be known for quite a while yet, but it will hopefully be a little piece of Lego that will be used to build a castle of new antibiotics. That's my hope.
That's really interesting. It's really interesting. Modifying the active site of the enzyme.
So modifying the antibiotic in such a way that it doesn't fit to the active site of the enzyme.
Yes, exactly. That is really interesting. Yes. Is there any light at the end of the tunnel? What is science being able to bring to us in order to rescue us one more time? Any new therapy in the corner? Okay, I like this idea that you just mentioned. But is there anything that we should know more about it?
You know, the field of science sometimes has the ability to progress in leaps, and sometimes it goes in a very slow pace. In fact, it was in 1929 when Fleming discovered penicillin. And in fact, it was, I believe, in 1550 BCE that the first recorded use of moldy bread was used to treat festering infections. So, you know, the history of use of antibiotics is old as civilization, but we are in very unprecedented territories. We are very quickly running out of alternatives. We don't develop antibiotics anywhere near as quick as they're being depleted. And, you might be hearing all this and thinking that this is very bleak. And this is the picture I want to paint. Right now, it really doesn't look very nice. There are companies which are trying to create new antibiotics. However, out of 15 pharmaceutical giants that we have, only 2 are now looking at having more antibiotics. So a lot of the slack is trying to be picked up by small and medium-sized enterprises. Not many very promising candidates are being found in the pipeline right now. So it is, quite grim. The interest has to pick up, and we have to be able to understand the foe a wee bit more. Not only that, but, having new antibiotics is incredibly useful. And we should be looking at more of that. And there's so many avenues of trying to do it. But on the other hand, we should be looking at slight alternatives. And one of the ones that interests me quite significantly is what's called a bacteriophage therapy. So if the Allies have used penicillin during the World War II quite extensively, the Russians didn't have that know-how, that scientific know-how. So what they have used were phages early on. So they're able to use viruses which only and selectively target specific strains of bacteria. And that was used on patients with gangrene and other illnesses on a battlefield. And in fact, it has very much fallen out of favor to penicillin and other antibiotics. But as the time progressed, there were few institutes still which were carrying on this work. And there is still one institute in the whole of the European Union which does treatment using phage therapies.
Oh.
And it's in fact found in my home country. It's in Poland.
Oh.
So this is, there's that single country in the whole of EU and is able to use phage therapy as experimental treatment to patients which are no longer responding well to other antibiotics. Because what we have right now is, some strains which are multi-resistant, so that means that they're resistant to many antibiotics, but then we have strains which are unfortunately pan-resistant, so they are resistant to all antibiotics. And I cannot imagine how stressful it might be as a clinician to see that report and seeing that every single antibiotic is not going to be useful against the bacteria that you have. But this is essentially what we are facing as it currently stands. So going back to the phage therapy, when being faced with a bacterial strain which is resistant to most, or if not all, of antibiotics, you should be able to administer a phage either directly on a wound or orally, or sometimes using IV in order to try and kill the specific strain of bacterium that causes that infection. And it has been proven to clear those infections. So that it works. It has been proven. It's still experimental, but it does work. In fact, I know that CDC is picking it up now, and they are beginning to use that also in the United States. So it's another sort of door, another avenue for us to keep open.
Yes, a light in the tunnel, kind of. That is really, really interesting.
Yeah. And as I've mentioned before, it's not necessarily as much of a treatment for resistance but it's more of a having a way of dealing with unwanted bacteria, which was the fecal transplant. There's another way in which we can try to fight bacteria, and it's not necessarily as much of making a new antibiotic, but to inhibit the disabling of antibiotic by bacteria. So we're looking at inhibiting the middleman.
Mm-hmm.
So this, in fact, happens right now with penicillin. So when administering penicillin, quite often what you will have are two drugs in a pill. One will be penicillin, and the other one will be clovonic acid, which will be able to bind to the penicillin binding protein that is made by bacteria. So rather than the penicillin being sequestered by the bacterial protein,
Mm-hmm.
it's going to be the clovonic acid, and that will be able to then sort of help for the antibiotic to carry out its function. And this is called an adjuvant therapy. And it is being explored with other antibiotics. For example, what I worked on, which is aminoglycosides. So, you know, there are avenues of trying to disable.
Yeah.
Mm-hmm.
Really, really interesting. Oh, thank you very much. Very interesting. And something that I get word in that I read recently as well is that the need of the government policy to change, because funding is always, as you mentioned in the beginning, is directed to something that can generate profits, actually. And the problem of antibiotics is that, okay, we need to produce new ones, but then at the same time, it's not going to be used often. And even so, the course of an antibiotic is short. So it's a very difficult situation for the...
That's very true. And that's why a lot of the big companies have managed to pull out of antibiotics, because there simply isn't really money to be made. I know that there are certain countries which are trying to sort of create government incentives to develop new antibiotics, which would potentially be something akin to what we've seen with COVID vaccine development. But we have to also be very careful that we don't end up in a similar situation like with COVID vaccine development, that the companies were taking all the money to develop those antibiotics and then reaping massive inhumane profits for what really has been funded by the taxpayer. So there has to, you know, it has to be a healthy amount of respect from both sides when also developing antibiotics. But yeah, I do want to just really make it clear that when you do finally end up developing that new antibiotic, you just do not at any point want to use it until absolutely necessary. So what that means is that those few doses of this antibiotic very often are going to be quite expensive, because the company that developed it, they want to, you know, get as much profit as they can ultimately. So it is going to be a difficult bridge to cross.
Definitely. Yes. Oh, thank you very much for accepting my invitation for the interview. It's really, really interesting, and it's very worrying. And I think it's important for everyone to be quite aware of what's on our plate, if we can say like this.
Well, thank you very much for having me on this podcast, and it's been nothing but pleasure. Thank you.
Oh, thank you.